Welcome to Test Prep Central. We're working Calculator Workshop 16, Graphing Inequalities. In the first example, you have the inequality y is greater than or equal to 2x minus 3. And we are asked to identify 5 solutions of that inequality. To start, I'm going to clear my memory. Second, plus 7, 1, 2. Go to y equals. Type in the 2x minus 3. 2x minus 3. To create an inequality, go all the way to the left until this symbol with the little square begins to flash and type enter. In the older calculators, you don't have the square and you don't have this menu. You just have to keep hitting enter to get the shapes that you want. But you can still do what we're doing. Go ahead and arrow down to line and arrow to the right. Now this first symbol here is a triangle pointing up and right. It looks sort of like a greater than sign if you look at it kind of sideways a little. So this is the symbol, or this is the shape we're going to use for all greater than or equal to symbols. Arrow down to OK and press enter to set that. So now you see that symbol instead of what was there before, which was a bold line. All right, next we're going to use Zoom 4 for our graph, Zoom 4. Now, in this particular graph, you'll notice that my grid lines are turned off, and I really want them on because it's kind of nice to use those to help us figure out the coordinates for order pairs. So type second zoom, and on the third row, at the end, highlight grid line and type enter. When you type graph, it will apply grid lines to your graph. All right, the older calculator models I don't think have the grid lines, but they do have dots, so you could use those, and they are helpful in helping you identify order pairs in a graph. All right, now this is something new. Before this, we have always used the trace button to locate solutions in a graph. But in an inequality, if you type trace, you are going to be on the line only. And we know that the solutions are not just the points on this line. It says y is greater than or equal to 2x minus 3, meaning all the points on the line and all the points above the line. So everything in this blue shaded region is a solution, and everything on this line is a solution. To get the points in the blue shaded region, just use your left arrows and right arrows, and you can move your cursor around the screen up, down, left, right in any direction, and all of the order pairs that you're seeing here at the bottom of your screen represent solutions. Now, I just so happened to choose integer solutions when I did this handout, but just know that I don't have to just use integer solutions. I could use these decimal solutions. Any of these solutions are correct. I chose 5 solutions, and the first 3 I chose were actually in the shaded region. I chose the solution -1, 0. Let me move this one down. The second one I chose on your handout was 1, 2. And the third I chose was 0.5, -1. Now, since this is greater than or equal to, that means this line, if you were graphing this, would be a solid line. If you were graphing it on paper, you would draw the line solid, and all the points on the line would represent solutions. When you type trace, the cursor will go to that line. The very first solution here it's giving me is the y-intercept 0, -3, and then you can type trace 2, enter, or just 2, enter, and it will take you to that order pair. And then if you want to type 3, and you could keep going. All of the points on the line are solutions, so choose at least 1 or 2 on the line and 1 or 2 in the shaded region, and show that you have got 5 solutions for this inequality. The next example, we have a system of linear inequalities. So let's go to y equals. The first 2 is not there. That is now a 1/2. So in the newer model calculators, type second y equals, not second, type alpha y equals, enter, and it will place a fraction placeholder here. If you do not have a newer model calculator, type 1 divided by 2, and it will give you the same thing, 1/2. All right, so the second row, or excuse me, the first row is no longer a greater than. It's actually a less than for our first inequality. So we will need to modify our shading. Go all the way to the left and type enter. Now instead of greater than, arrow down to the line, press right one more time, and now see that this is pointing down. I think of it as an L shape. Less than looks sort of like an L. And then arrow down to OK, type enter, and now you will see it say less than. I'm going to go to the right to get out of here, and then I'm going to use my down arrow to go to Y2. Now Y2, my second inequality, type negative, the small negative at the bottom of your screen, 2x plus 4. Arrow left, type enter. Arrow down, where the line type is, type right once, twice. Now, well, excuse me, just once. I would like for this shading to go up. Now, if you happen to hit enter too many times, you'll see all these different shapes. Just keep hitting enter. It will go back around, or you can hit the left arrow to go the other direction. On the older model calculators, you only have the option to hit enter. So it will you'll have to cycle back around if you go too far. Type enter or type OK and then enter. Now notice that one is greater than. Now here's something to remember. If you only have a less than and not a less than or equal to, that means the points that are on the line are not part of your solution set. The same is true for just a greater than. If there is not a greater than or equal to, then the points on the line are not part of the solution set. Now, when we graph these on paper, we use a dashed line to represent these lines. In the calculator, however, at least with this particular calculator and the other TI calculators, you cannot create a graph with both a dashed line and a shading above and the shading below unless you're using an app. There is an app that will allow you to do that, but I would discourage you from using the app simply because you cannot use the app on a state test. You cannot use the app on the ACT, and so it would be probably not good to get in the habit of having that. So I'm just going to have it look like it would if you were taking your state test and using this particular feature in your calculator. So what I'm trying to say is when I type graph, it's going to show me the two lines solid, but on paper I would not graph solid lines. I would put dashed lines on my paper for these two lines. Now the solutions for a system are not just in shaded regions, but they're in the overlapping shaded regions. So down here in the bottom right it sort of looks purple. In this region there are solutions. There are no solutions here because this doesn't include the ordered pairs that go with the first inequality, and there's no solutions here because it's missing the ordered pairs for the second inequality. Again, I will not use points on this line either. I will only use points in the shaded region. So from appearance, if I use these grid lines, 1, 2, 3, 4, 5, 6, 7 is off the screen, but it looks like 7, 0 would have to be a solution because it would be in the shaded region. 6, negative 2 would be right in here. That looks like a solution. 5, negative 3, that looks like a solution. So on your handout, I've listed those three ordered pairs as possible solutions. And of course, there's infinitely many more. So just choose any ordered pair, including decimals and fractions, that are in this shaded region that overlaps in your graph. Now, to verify that those are solutions, another strategy is to use the test menu. So I'm going to go to second mode, or you can just type clear to get out of here. What we're going to do is take the first solution I gave you, 7, 0, and test it. And here's how you do that. You type 7 store x, enter, and 0 store alpha 1, enter. Now what I will do is I will type both of the inequalities. If this ordered pair makes the statement true, then I will get an answer of 1. And if this ordered pair makes this statement false, I will get an answer of 0, and I will know it is not a solution to the inequality or to the system of inequalities. So the first thing in the first inequality is y, so we'll type alpha 1. Then we have a less than, so that's second math 5. Then we have a half, so that's alpha y equals, enter, put your half, arrow right, type x, minus 3. Okay, so if this is a true, if this point makes this statement true, it's going to say 1, and it does. So that's telling me this is true. So that's good. Now we must check both inequalities. So let's do this with the second inequality. Alpha 1 greater than is second math 3. Then negative 2 x plus 4. Again, I'm getting 1 for the answer, meaning this is a true statement. And now I know 7, 0 is a solution. Now this is a little bit time consuming, but if you have something that's very difficult to graph, or you're just not sure, or you don't want to graph, you can always use the test menu to test points this way. All right, the second point I gave you was 6, negative 2. So I'm going to clear this out, and I'm going to store 6 for x. So 6, store x, enter. And I'm going to store negative 2 for y. Negative 2, store alpha 1, enter. And then I'm going to type the two inequalities again. So alpha 1 less than is second math 5. 1/2 x is alpha y equals, enter, 1 divided by 2 times x minus 3. Enter. That statement is true. Now we'll test the other inequality. Alpha 1, enter. Whoops, didn't mean to do that. Let's try it again. Alpha 1 greater than is second math 3, negative 2 x plus 4. Enter. That solution is not a solution. The answer is 1, and it's telling you this inequality is true for those stored values of x and y. All right, I'm going to clear my screen one more time, and we'll do this one more time with the point 5, negative 3. So I type 5, store x, enter. And then the y is negative 3. So negative 3, store alpha 1, enter. For the first inequality, type y, alpha 1 less than second math 5. 1/2 x, let's do this. 1 divided by 2 x, same thing, minus 3. Enter. And I got a 1. The next one is y, alpha 1 greater than second math 3. Negative 2x, negative 2x plus 4, enter. And as you can see, the more you type this, the faster you get. So some of you probably went faster than me. But there you have all true statements. So that's telling you that all 3 ordered pairs are solutions to the system because they made both inequalities true. Example 3, it says graph the system of inequalities and then use a scatter plot. Okay, well, let's see. I believe we have the same system of inequalities, so that's convenient. We will not need to change this. But what we will do is go to Stat Enter, and we're going to put our ordered pairs into a scatter plot. So the x-coordinates will go in list 1. So I'm typing -2, that's my first x coordinate, and then 3, 0, 1, and 6. Let's make sure I've got them all. Okay, and then go to y, or list 2 to put your y values, your y coordinates. So 1, 2, -3, -1, and 6. All right, to see these, I need to turn on my stat plot. So type second y equals, enter, enter. And it does show a scatter plot using list 1 and list 2, so that's all good. If you want to change the color, that might help it stand out. I did not do that in your handout, but let's go ahead and do it to do something different here. I could make it red, black, magenta, green. Green looks good. All right, so when I type graph, yeah, that green does stick out pretty good. So you'll notice in the graph that some of the points are in, oh no, actually none of these are solutions because none of these are in this overlapping region. But you know what happened here is I was not paying attention, because notice that the first inequality has the same values 1/2 x minus 3, but what's different is that is actually greater than or equal to. So I should not leave my shading going down if it's greater than or equal to. So let's go make some changes here. Highlight and type enter, and let's make this greater than, which means I need to go back one. It needs to point up like that and to the right, greater than. Okay, then the other inequality is less than or equal to. So go to your second one and type enter, and then let's go down and let's go right. There we go. There's less than. Now it's not equal to, so we're going to have to remember that. Let's type enter. You can type enter twice to get out. Now when I go back, this looks better. All right, now finally I have some solutions. I had none before, but now I have a solution in this shaded region. I have this solution here, and I have a solution out here, but this is not a solution to the system because it's not in the shaded region for the red. This is why the color is so helpful, because you can kind of tell which inequality is which. This point is on this line, but if you'll, and in the first line is actually a solid line. So this is a solid line because it says greater than or equal to on this one. So what we'll do is we're going to type trace, and this is showing you the point -2, 1 is a solution. When you go to the right, it's going to show you this point, and this point is a solution to the first inequality because it's in the shaded region, but it's not to the second inequality, so it would not be a solution to the system. This one is a solution to the first inequality, and since the first inequality had an equal sign, it is a solution. And then go right again. This point is a solution to both, again, because it's in the shaded region for both. All right, so if you will look at your last page, or page 4, I've got all 4 of those and a detailed explanation about which points are solutions and which points are not. Now, something really important to do is to know that you can get on these lines. Now, you will be on the points, but if you press the down arrow, notice at the top here, it's going to show you the line that you're on. So this point is on this line, and this line has an equal sign in the inequality symbol. Y is less than or greater than or equal to. So that's why it's helpful to use the down arrow to get to the other line. When you type down again, it's going to go to the last inequality, and there it is. And so you can go along this line to see, or you can even type numbers to get points on the line. So if you go back up, it's going to go to the other line, back up again, it'll go back to the plot. So if you need to trace on the line, just hit the down arrow, trace on the plot, to go back, hit the up arrow. All right, so that's what we have for inequalities. Remember, if you get stuck or make a mess, you want to just start over. 2nd plus 7, 1, 2. You will need to turn your grid lines back on. You will need to adjust your window. I do recommend Zoom 4 for pretty much all of these. If you don't use Zoom 4, you're going to get some pretty ugly numbers when you use your arrows to locate points within your shaded region. Don't forget that an answer of 0 using the test menu means it's not a solution. In fact, let me do this right quick. Let's say, let's pick a point in this graph. Let's pick a point over here. 1, 2, 3, 4, 5, -3. Let's just make up a thing here. I want you to see one that's not true. So let's say, I want to say 5 is less than -1. So I'm going to go to second math and do 5 and then -1. Now we know that's not true. 5 is not less than -1. 5 is greater than -1. So when you type enter, it will return a 0. That's a false statement. So whenever you see a 0 when you type enter using the test menu, you will know the point you're testing is not a solution. You need to choose another point. Okay, that's all I have in this final workshop of this series. Hopefully you've learned something new. Don't forget, the best way to master your graphing calculator is to make mistakes and fix them, and to practice, practice, practice. So enjoy. Have a great day.